the notes. Okay.
Perfect.
Well, welcome to Machine Learning for Social Good. Machine learning is a very powerful technology that I believe we've only scratched the surface on the ways that it will impact our lives for the better. When I first started learning about machine learning, for me, it was honestly a scary topic. I thought that you needed to have a PhD and you're working in a research lab really in order for you to grasp machine learning and just understand how it can be used. But thankfully, through a lot of the services and tools on AWS, no PhD is required. You can learn more about data science and explore artificial intelligence and machine learning in fun and engaging ways. And we'll talk about some of those ways today. Just a little bit about me before we get started. I've been in IT for 25 years. That is a very long time. Most of that time, I served as an engineer, a software engineer, either in a technical lead role, an engineering role, or an engineering manager role, focusing mainly on Java. So my entire career, I've built a foundation on Java. And probably 3 or 4 years ago, I started dabbling with machine learning. Like I said before, I thought it was this complex technology that was just so far out there and that it didn't really have ways that it could be applied in the real world. And so I started playing around, and now I'm officially a machine learning practitioner. I try to use machine learning to solve every problem there is. Since that time, I've created models to predict crime, and we'll talk about what is a model. When I say that word model, just think of an application. I've created machine learning models to predict crime, detect emotion, classify footwear, generate music. Now that project was a lot of fun, and even stop sodas from disappearing out of my refrigerator. So the story there, I have 3 kids, they love soda, and I set up the AWS Deep Lens, which is a deep learning enabled camera to alert me every time someone went into the refrigerator and tried to steal soda. I'm currently what's known as an AWS machine learning hero, and that's just a recognition from AWS for just always being out in the community, sharing my lessons learned, and talking about machine learning. I'm also an Alexa champion, and currently I serve as a training architect with a company called A Cloud Guru. How can machine learning be used in the real world? The first way machine learning is used to predict crime, and we'll actually look at one of my fun little side projects that I created to predict crime. In this example, it's showing you a hotspot map, and so machine learning can be used to identify what they call hotspots or areas in a city where crime is likely to occur. And in this image, it shows, if you see the red right in the middle, there's an 85% chance of an assault occurring. So machine learning can be used to predict crime. This is another really cool real world scenario of how we use machine learning. And this is facial recognition used by Delta Airlines to allow you to check in without having a boarding pass. So facial recognition is made possible by machine learning, and in this case, it really adds a level of convenience. Next, machine learning can be used, and it is used, to detect fraud. So for example, credit card fraud. There is a model, and it basically watches all of the transactions coming through, and it identifies the possibility of fraud. So in this case, this transaction has an 85% chance of being fraudulent. There's information or an explanation that is then sent to a human to review. So it's a great way to protect our money and our bank accounts. I'll sign up for that. And then it's also used in hiring. So there are some machine learning models that can tell if you would be a good fit for the place that you're trying to work. And in this scenario, I really like the thought of using machine learning because if we're using it correctly, it can actually remove human bias from the hiring process. It's also used in loans, so determining if you'll get a car loan or a home loan or that small business loan. And here again, if it's used correctly, it can remove bias from the process. And then this use of machine learning really excites me because it is literally life-saving. And so here in this example, this is where a machine learning model is actually detecting lung cancer, and it outperforms humans in this process. And so just thinking about using machine learning to save lives, that is really for social good. And machine learning can even be used to help us better understand and predict impacts of this global pandemic that we're all dealing with right now called COVID-19. And I'll talk more about that. So today I'm going to introduce you to machine learning, what it is, how it works, how it can be used to battle a global pandemic. We'll look at my public safety use case. And if we have time, we'll take a look at an emotion detection use case that I have. And then we'll talk through using machine learning to battle COVID-19. And then we'll have next steps and a Q&A. What is machine learning? At the highest level, whenever someone asks this question, you'll get the response, it allows a computer to produce output without being explicitly programmed. But what does that really mean? So I'm assuming that I have a lot of developers and engineers in the room. And when we write an application, we are really used to writing those applications to tell the computer what to do. So we use Java, Python, Node.js, and we define explicit steps for what the machine is supposed to do. So we'll add decision statements, we'll add loops, but it's us telling the machine. With machine learning, the approach is different. The machine can actually produce output without us telling it how to achieve that outcome. And it is just, it's really cool. And so instead of building an app or producing an app, you are generating or creating what's called a model. And that's what I have on the slide. And so the model is, all it is, it's a mathematical representation of trends and patterns found in data. And once you have this model, it's like this all-knowing oracle that you can consult. You can send in data that it's never seen before. It's going to take everything that it's learned, review that data, and then give you what's called a prediction or an output. So let's talk about the process to actually create this model. And the process is different from the more traditional software development lifecycle. And as a software engineer coming from a strict Java web development background, I really had to go through and learn this data science process and how you structure a machine learning project. And I spent hours researching and weeks learning and practicing. And the first step is, sounds simple enough, is obtaining data. And sometimes it's really hard to obtain reputable data. And when you're dealing with machine learning and machine learning models, data is the most important piece. And I always tell people, think about it like this, like garbage in, garbage out. So data is king. It's the most important piece. And so once you obtain the data, I would say 99.9999999% of the time, it's not in the format that you need. So it's not in a format that a machine can easily learn from and find trends and patterns in. And so there's this lengthy process to clean, prepare, and transform the data and get it ready for machine learning. And that's this preparation stage here. And once you have the data, you actually have to go through what's called training. And so this is where the machine actually reviews the data, really searches and tries to find trends and patterns, and then it produces the model. And this process happens multiple times. And so during training, there will be multiple models produced and evaluated. And at the end of the training process, you'll have this well-performing model, for example, a model that can predict crime. Then once you have the model, you productionize it. And I don't even know if productionize is a word, but I like to use it all the time. But that's where you take the model and you put it in a production environment so that others can use it. Sounds simple enough. And when I was learning machine learning, I had to go through the process of just really understanding what machine learning could do. So what type of answers can I ask a machine, and what answer will it give me? And so I learned about regression algorithms where it returns, the machine can tell you a number. So for example, what will the temperature be in Las Vegas tomorrow? A machine can answer that question. Next, we have classification algorithms where the machine can look at, let's say, 3 or 4 things, maybe more, and classify that. It's called multi-label. So for example, in my emotion detection example, is this person happy, angry, or sad? And then binary, that's a yes/no answer. Is this person a threat to public safety? And then we have clustering algorithms where the machine can actually find trends and patterns and group items or group people. And this is used a lot for companies to understand like who their customers are. And then we briefly touched on how machines learn, and it's through the training process. So there's supervised, you'll hear supervised learning, unsupervised learning, reinforcement learning, and supervised learning. That's the example I'm about to show you, but that's where we train the machine using data that already has the answer that we're trying to predict. And then unsupervised learning is where the data is unlabeled, and reinforcement learning, you see that a lot in robotics, and that's where the machine receives feedback during the training process. So let's talk about this public safety case study that I created. At a very high level, this is the architecture. And so initially you'll have an image of a person that is uploaded to AWS. So AWS has a lot of AI and machine learning services that really make machine learning approachable. And so my public safety use case, the entire architecture runs in the cloud on AWS. And so there's an image that's uploaded to what's called an S3 bucket. Just think of the bucket as file storage in the cloud. So I load a file to S3. That process then triggers a piece of code called a Lambda. And this Lambda, I believe I authored it in Python, but you can use Java and a lot of the popular programming languages. And so this Lambda, think of it like the controller. And so it takes that image and it sends the image to Amazon Recognition, which is a computer vision service that when you send an image, it is able to identify or label items in that image. And in this case, the initial image, it can determine the age of the person and the gender of the person. And then that information, along with additional information like the time of day, day of week, and month, all of that is then fed to the Amazon StageMaker service, which I use to create the crime predicting model. And so the model takes in all of that data and makes a crime prediction. And then the prediction, either yes or no, is sent back as an email through the Amazon Simple Notification service. So when we talk about the data that is fed to this model, this is an example. So I'm showing you here the input and the output. And so the question that in this use case that I'm asking the machine is, what is the likelihood of crime? And the answer or the output that I get back will be either yes or no. And in this case, it's supervised learning that uses the binary classification that I mentioned. On the left-hand side under input, you see the data points. And this is a numeric representation of the day of the week, month, age, gender, time of day, and location. And on the right-hand side, you see the output. 1 means yes, and if it was a 0, that would mean no. And so in this case, with these data points, crime is highly likely. So this was supervised learning with labeled data, binary classification that returns a yes or no answer. One very important thing that I do want to call out with this model that I created, and I actually created this back in 2017, so that's a long time ago. And when I created this model, I was very concerned about bias. And so we hear about bias in machine learning, and bias typically surfaces through the data that we feed to the machine learning model or through what the programmer or engineer tells the machine is important. And specifically for this crime predicting model, I did not want it to ever be used for racial profiling, and I did not want it to be accused of racial profiling. So when I built out this model, I intentionally removed race as one of the factors used to determine whether or not crime was likely. And this project here, I was actually able to present about it on the TED stage in New York City. And it was just a really fun project where I learned a lot, and it showed me how important diversity is when we're building machine learning and AI systems. So now let's get to the fun part. This is the code review. I'm going to walk you through this Jupyter notebook that I have. Okay. Yes, I can see that. You guys can see that. And so I have 2 monitors. So you're going to see the side of my face for a little while while I look over here. So this is my Jupyter notebook. At the very top, I'm just importing some of the important data science libraries like Pandas that allows you to work with data, and NumPy here that allows you to work with multi-dimensional arrays. Data ingestion. In this section, basically what I'm doing, I'm pulling in the data files, and that's something I wanted to show you. Let's see. Okay. So when I went through the process of training this machine learning model, I needed data. And I searched and searched, and the only place in the world where I could find police departments that actually made this data public was in the UK. So this crime model only works for the UK. And I was able to pull like years worth of stop and search records. So stop and search records basically show we stopped this person, this location, these are the attributes about this person. This stop led to an arrest, or no, it did not lead to an arrest. And when you're working with supervised learning, remember I told you that you have to have labeled data that's labeled with the answer. And so if you look in this column A here, 1 means that this information or this row led to an arrest. And if I scroll down, well, there are a lot of records, but there are rows that have 0. That means this did not lead to an arrest. And then here you see it's the location, time of day, day of week, month, gender, and age. And so this was the original data. And I'll show you the Python code that I needed to write in order to translate or transform the data to this. So if you notice in this second file that I'm showing you, everything it's numeric. And so the machine learning algorithms that that I worked with, and most machine learning algorithms cannot take strings as input. And so that's a big part of cleaning and transforming the data and putting it in a format that a machine can learn from. And so this is the actual final data file that I fed to the machine during the training process. So let's go back to the code. Okay. And so here, this is where I'm reading in the data. And then I went through this process of trying to just understand the data. Whenever you're working with machine learning, having that domain knowledge of the data is very important because it allows you to spot anomalies or issues with the data. And remember, like I said, bad data in, bad model, bad predictions, biased data, biased predictions out. So it's very important for you to really have that domain knowledge. And so here I'm just going through the data. I'm using data frames, just trying to understand the data. Here I'm in cell 3. I'm inspecting the data. Cell 4, I'm using a histogram just to understand how the data is distributed. Then in cell 5, I'm looking at the relationships across the different columns. And so you'll see for Dorset County in the UK, there are 259 records where there's no crime and 143 where there is crime. So just going through and understanding the data distributions. And I feel like I really understand how crime works in the UK. And so like you never want to go to the UK and visit Hampshire in the summer because there's a lot of crime that happens. And then here I'm just understanding the breakdown of my data based on gender. And then there's this cleaning process where I went through and I got rid of null or empty records because you don't want your machine, you don't want the learning algorithm to learn from null or records that are empty. And so I went through this process to actually clean up the data and get rid of that. And then remember that first file, it had strings, and the second file had nothing but numbers. So this is where I go through and transform and clean up the data. And so for example, there were a few fields where I could easily translate those strings to numbers. So for example, for day of week, whenever I saw Monday, I replaced it with a 1. And the same for months. Whenever I saw January, I replaced it with a 1, December, replaced it with a 12. And so that method is called the find and replace. And then there is another technique called one-hot encoding. So for example, in the gender column, we have male and female. And so what one-hot encoding is going to do, all of the unique values now become columns. So for example, if you look here in cell 14, now we have two columns, one representing female and the other representing male. And then based on what that value is, you'll either see a 0 or 1 in that column. And so here for row 0, this record represents a male. And so I had to do that for the rest of the values. So for male, for day of the week, and time of day, and county. And so you'll see that here. This looks exactly like that final training file that I showed you. That was all numbers. And then I went through this process of actually taking that data and separating it out into training, validation, and test data. So during the training process, while the machine is learning, it will actually evaluate itself based on this data to see if it's really doing a good job at predicting crime. And then here I'm just uploading the final files to actually kick off this training process. Out of the box, StageMaker comes with Jupyter notebooks and several learning algorithms. And because I was trying to predict a yes or no answer, I used what's called the linear learner algorithm. And so, let's see. Yes, so here. So I'm calling it learner, but the estimator is a linear learner. And then I'm setting hyperparameters. So whenever you train a machine learning model, you pass in configuration parameters, and they call them hyperparameters. And so the most important one here, well, the predictor type, binary classifier, meaning yes or no. And then the epochs, that's how many times or how many passes the machine is going to make over the data, trying to find trends and patterns. Right now I have it set at 15. In a real world scenario, it would be much higher than that. But the more epochs you have, the more costly training becomes. And so I just have here all of the metrics from the output from training. So I'm going to jump down to the very bottom. And so at the very end of the training process, this metric shows the accuracy. And so right now, after this training, the crime prediction model has an 85% accuracy. Now, for me, that's not high enough, so I would probably need to increase the epochs and do additional training. Also with StageMaker, once you have this model, you then, remember I told you you can productionize a model? And what you do, you use the model hosting on StageMaker, and then it actually gives you a URL where you can send in a JSON request to the model and get the response back. And it's really cool. So in this example, I'm just setting up the model for hosting in cell 33. And then I'm doing some validation. And then in this example, I'm running an inference. So that's where you send in data and you get the prediction back. And so here, this data that I'm sending in shows the day of the week, month, age, gender, location, and all of that. And then basically what it's saying here, this one, that this represents crime, and it has a 97% accuracy that it's correct. And then at the end, I'm removing the endpoint. So that is a quick look at the crime prediction model. I'll be hosting some workshops next week where we will go in much greater detail. So in the final few minutes that I have, let's talk about using machine learning to fight COVID. There are several ways or several use cases that we can use to fight COVID. For example, we can use computer vision to determine if someone is wearing a face mask. Or we could use computer vision, which is a form of machine learning, to determine if people are social distancing. We can use a machine learning model to predict if someone will catch it when they are exposed. We could use a machine learning model to predict patient outcome and recovery. We can use it to project the spread. And we can also use it, and I think this use case is super cool. We can use it to determine by looking at x-rays if the type of pneumonia that we're looking at, if it's regular pneumonia or COVID-19 related pneumonia. So that's just a few of the use cases that I came up with. There are a ton more out there. And so, like I mentioned, next week, starting next week, I will be hosting a series of machine learning workshops. I know a lot of what I covered today was at a very high level, and that's why I wanted to have these additional workshops where we will go really deep in how we use machine learning. And I'll introduce you in the first workshop to all of the tools like Amazon StageMaker, Jupyter Notebooks, some of the Python data science libraries that I mentioned. And then in the second workshop, I'll talk to you about data and how you get it ready, transform it, and prepare it for the machine learning process. And then in the third workshop, I'll talk to you about and show you how to train a model using AWS SageMaker. And the great thing about this, AWS will give everyone that participates in the workshops $200 credit. Because with SageMaker, it's a service that you have to pay for and it's not cheap. So $200 will go a long way in helping you learn more about AWS and machine learning. And then finally, at the end of the workshops, we'll have a hackathon. So you can take everything that you've learned during the 3 workshops and form teams to go off and build some type of machine learning model that can be used to battle COVID. And so it's a hackathon, and we will have judges from AWS, from Women Who Code, and the winning team actually walks away with 1 year free access to a cloud guru, and that's the company that I work for. And we have a lot of online training that help prepare you for certification exams across all of the major cloud vendors. And the winning team, each person on the winning team will also receive $5,000 in AWS credits to continue their learning journey and build out their model. And so after today, what's next for you? I really hope that you all join me in the workshop starting next week and also join the hackathon. Okay, that's it. Time for Q&A. Let's end this show. Get back to, okay.
Thank you so much. Your presentation was incredible and getting so much good, great feedback from the chat. And for everyone viewing, we have posted a couple different links for how you can sign up for the data science series, as well as the YouTube channel for where this is being recorded and will be posted probably next week. But at this time, does anyone have any questions they would like to post to the chat, and we can go ahead and get started on answering those?
Okay, I see one at the very bottom. What level is your workshop geared toward? So this workshop will be for someone who's never, you have programming experience, but you've never worked with machine learning. And so I don't assume that you have machine learning knowledge. And if you're someone that has a lot of exposure to machine learning already, then you can definitely skip the workshops and just go straight for the hackathon. Would we be able to get access to the Jupyter Notebook? Definitely. I can share that link. What do you do after you complete a model? Okay, that's a great question. So think of the model like an application. So once you've created this model, you then need to put it in a production environment where other systems or other applications can actually use that model to make a prediction. It's a lot of questions. It's scrolling so fast. I'm sorry if I skip a question. Okay. Can we talk more about bias and if it is still okay? So this is from Carmen. Anytime you are working with what's called a protected attribute, so things that can cause discrimination lawsuits like race, gender, and age, there is always a possibility of bias entering or coming into play. And so as a machine learning engineer, there are a lot of techniques, there are a lot of things that you can do to reduce bias. For me, when I built that crime prediction model, race was a big factor for me, and I did not want race to ever play in determining whether or not crime was likely. And so for me, I took it out. I just totally removed it. And so, yeah, there's always an issue when you're dealing with what's called protected attributes. Is there anything we need to prepare before, like sign up for an AWS account? Yes, it would be great if you go ahead before the workshops, go ahead and sign up for a free tier account. And then during the workshops, I will hand out the $200 credits so that you do not end up with a big bill. And I can tell you the very first time I started using StageMaker, my initial bill was higher than my car payment. And I had a freak out moment.
Oh
So
my.
yes, yeah, we will have credits for you.
That's great. And I just wanted to give a 5-minute warning. We do have sessions starting at 2:30. So
Okay,
everyone feel free to give a couple more questions at this time.
okay. Next question, statistics, math background. That is a very good question. You definitely have to understand like linear algebra and things like that, but you don't have to be like a PhD level math to really get into machine learning, especially with the like the AWS SageMaker service. It abstracts away a lot of the complexities and it really makes machine learning approachable. So yeah, definitely join us. What is the most difficult task? Data pre-processing, feature selection, and they're all difficult. They're all difficult. For me, the most time intensive is the data pre-processing. And I think a lot of people that are new to machine learning, that's something that they often underestimate. That is the part that takes the longest. And it's really the most important as well. Great question. Next question, is this language agnostic? Not really. So in the workshops, we're going to use Python. And you don't have to be a Python expert because, like I mentioned to you all at the beginning, my background is Java. I've been doing Java forever. And so I'm not a Python expert, but I know enough to train a model. So yeah, we're going to use Python. How do we address issues of unconscious bias, specifically when we are not necessarily aware that we as, okay, so this is talking about bias and how do you address bias? When we're talking about machine learning, bias is a very huge issue. You know, we've seen the computer vision models that don't recognize or can't see Black people, or we've seen issues where machine learning models have classified African Americans as gorillas instead of human, or we've seen AI recruiting models that have been biased against women. So for me, what I always tell people, it's very important to have diverse teams actually build and test these models before they're ever released and used in production. So for example, the machine learning model that actually classified African Americans as gorillas, if I were a developer on that project, I would initially test the model on me on myself. And that would be a big red flag right there that there was an issue with the model. And so diversity in building and testing will help improve the overall process. How much time do we have?
A couple more minutes.
Okay.
The next round of sessions begin at 2:30.
Okay. Is this Python based? Yes, we'll be using Python. What have you done on your own for machine learning outside of your job? Well, machine learning is not my job at all. I started in 2017, just really wanting to learn more about machine learning and how it worked. And I'm still on this journey. And so all of the models that I've created, everything that I've mentioned to you all, it's really just something that I do as a hobby on the side to really learn and explore. And that's how this entire workshop and hackathon series came out. I've played around a lot with supervised learning, and I wanted to just explore more about unsupervised learning. And I also wanted to use machine learning to battle COVID. And so that was going to be my summer project, something I was just going to do to learn. And I thought, well, it would be really cool if I could bring others on this learning journey with me. And so, yeah, everything that I do for machine learning, it's just really to learn and improve and try to figure out new tech and how it works and how it can be applied. Next question, I have an MS in data science degree, but I haven't used AWS. What's the best way to start learning about it? So we'll be using AWS in our workshops, and I will not assume that anyone has had AWS experience. And so really the best way to start playing is to come up with a use case and just get in there and get your hands dirty. I would recommend starting with Lambda if you are a developer or an engineer. Lambda, it allows you to write functions in various different programming languages, and it makes the transition to the cloud very easy. Okay, is there a way we can make sure that the already existing models do not continue to perpetuate biases directed toward minor? It's all through testing. The only way that we can really identify bias is to do a lot of testing with these machine learning models before they are released to production. And I am a real advocate of some type of third party really going through and testing these models that can actually impact people's lives, like the models used in courthouses to determine if someone is going to be a repeat offender, or the models used to determine if someone is going to be a good fit for the company they're applying for. I'm a huge advocate for having third parties actually test those models for bias and providing sign off before they're ever really used in a production environment, because bias in machine learning is a huge issue, so much so that I've seen news articles and reports where cities are banning facial recognition and other machine learning technologies. And for me, the problem is not the technology, right? The problem is the fact that it's biased because the engineers that created it use biased data. And so if you feed biased data to a machine learning model, then it's going to give you a biased result or output. And so, yeah, bias is a very huge issue. And we all, when we're developing machine learning models, we all have just a responsibility to make sure that what we're producing doesn't negatively affect someone's life. Okay, I see a lot of questions still, but I think we're out of time.
We are.
It's a lot of
Thank you
questions.
so much. I know, so many questions. I will share this chat with you because I'm sure these will come up in your upcoming series.
And just to let you know, I've seen the registration jump by about 100 people since you started speaking.
Awesome.
So I think
Awesome.
everyone here just signed up.
Awesome.
Thank you so much. And I'm so glad you were able to give this as a preview to your upcoming series and hackathon.
My pleasure. I'll see you all in the workshops.
Yeah, thanks, Kesha. Bye,
Bye.
everyone. The next sessions are starting at 2:30 my time. I don't know what time it is for you. Head to sessions and we'll see you.